Okay, welcome back to my series on financial maths. This is the third video of 5 or 6 videos. Last video we looked at simple interest, word problems. Now we're going to be looking at compound interest when the compounding period is 1 year. Okay? And so next video we'll look at when it's compounding fortnightly and weekly or 6 monthly. We'll have a look at some examples, but for now it's just compound interest, compounding yearly. And we'll look at calculating unknowns by rearranging the compound interest formula. Time to get started. All right, so you may want to pause the video and attempt these questions, these 3 questions. And then you learn better that way, really. So let's do it. So compound interest this is the formula we're going to use. Okay, so we derived this in our first video. A equals P times 1 plus I to the N. A is the amount of the investment, P is the principal or the initial amount invested or borrowed. I is the interest rate as a decimal. So to calculate it as a decimal from a percentage, you divide by 100. N is the number of years. And then this bit here, so once you have the amount, you can calculate the interest. And this formula is just from the formula A equals P plus I. So the interest earned is capital I. We've got A as the amount, P as the principal from over here. Okay, so first one. Tayla owes $5,000 on her credit card. All right, so I'm just going to put down P equals 5,000. And compound interest, okay. I'm going to write down the compound interest formula. I think that was my stomach that made that noise, I swear. So we've got, I'd write down the formula straight away. Okay. Tayla owes $5,000 on her credit card and compound interest at a rate of 13.24% per year. A rate of means an interest rate. 13.24% per year. If we want to convert that to a decimal, we are dividing by 100. We're making it smaller. We're moving that decimal to the left. 0.1324 per year. Always include the units after it. She does not use her card again, but also does not pay off any of the money that she owes. Okay, so she's still paying interest on all of this money. Even though she's not using her card again, she hasn't paid any back. Okay, so let's have a look. Find the amount that she owes after 4 years. All right, after 4 years. So that will mean that N equals 4, right? And let's put the units after it. The amount that she owes after 4 years means our little A equals P times 1 plus I to the N. Then we substitute. So our P is 5,000. 1 plus I as a decimal to the N, which is our number of years. Oops. Then let's just put that into our calculator. 5,000 times 1 plus 0.1324 to the 4. That gives me $8,221.85, rounded to 2 decimal places. Okay. And maybe, oops, I'm going to move this formula up here, actually. Sorry for that frustrating move here. Okay. Don't forget that little N. That's what I'm worried about. Okay, so part 2. Find the amount she owes after 10 years. Okay, so same formula. A equals P times 1 plus I to the N, compound interest. After 10 years, N equals 10. So we've got P is 5,000 still. 1 plus I as a decimal, 0.1324 to the power of 10. Into the calculator it goes. 1 plus 0.1324 to the 10. Have I done something wrong? Because I've got a giant number here. I'm just going to 5,000 times 1 plus 0.1324 to the 10. Yeah, that's right. Okay, it is $17,336.79. Oh, wow. So she just borrowed $5,000, but she's left it for 10 years. She's not paying it off, and it's a pretty big interest rate. She's got $17,000 to pay off now, from $5,000 to $17,000, because she was slack and not paying off the money that she owed. So be careful, all right? It's unbelievable. Okay. Calculate the total interest accrued over 10 years. All right. So like I said in disbelief just then, that's a lot of interest. All right. If we come back to here, to our 21, we've got this formula, right? I equals A take P. I equals A take P. All right. So A, which is, where were we? Oh, yeah. Our amount after 10 years, right? Because we want the total interest accrued over 10 years. $17,336.79. Take our initial principal, $5,000. See where it gets us. 17,336.79. Take 5,000. She is just loving giving the banks all this money. $12,336.79. Probably could have done that in my head, but it's okay. 17 take 5 is 12. Oh well. All right, so she owes them quite a lot of money. I mean, she's just paying this amount in useless money. Anyway, don't get me started on interest. All right. So that is the total interest she's accrued over 10 years. Pay off your credit card debt immediately is the lesson here. Okay. Okay, next one. Brad wants to buy a car. He borrows $5,500. I'm going to make my data table as I go. He borrows $5,500. That is the initial value. That's the principal. Okay? $5,500. At 7.5% compound interest. Okay, that's our little interest rate. 7.5%, but we need to convert that to a decimal. And we do that by dividing by 100. Okay, moving that decimal 2 spots to divide by 100. Gives us 0.075 because you just put a 0 underneath that hump there. And I always include the units after, per year. Okay. For 3 years. N equals 3 years. Okay. A. Determine the total amount of money owed after 3 years. Total amount of money owed after 3 years. Okay, well, I'll write the compound interest formula because we've got to determine the type of interest. And it's compound interest. It's not that PIN formula. That's for the PIN formula. That's for simple interest. So make sure you have the right formula to begin with. Okay. Let's do it. The total amount of money owed after 3 years. A. We're finding A. substitute in from our little data table. P is 5,500. 1 plus little I as a decimal to the 3 into our calculator. 5,500 times 1 plus 0.075 to the 3. 6,000, put your dollar sign in, $6,832.63. That's the total amount he owes after 3 years. All right. Okay, it's a pretty, yeah, I don't know where I was going with that. Let's go B. Find the amount of interest owed. So careful not to get confused with, see how it says amount of money, amount of interest. Lots of words. They're just saying find the interest owed. So if we come back here, interest from this formula, I equals A take P. I equals A take P. So I'll just write I there. A was from back here. They usually, they can step you through the question. So don't forget the variables that you've already found. So I've got A as $6,832.63. Take away his principal, which we know was what he borrowed, 5,500, into our calculator. 1,000, oh, make it a dollar sign, $1,332.63. That's the total interest he owes. Okay. Try it out. And this is the final question. So well done for making it this far, okay? Okay, $2,500 is invested. Okay, well, we know that that is the initial principal, that initial value. Write it straight down into your data table. At 5.5% compounded annually. We've got a percentage, which is our rate, 5.5%, okay, per year. But we need to convert that to a decimal. So we divide it by 100. And how do we do that? Move it that decimal place 2 places. And replace under the hump with a 0. 0.055 per year. Okay. Compounded annually. All right. Well, I'm just going to write the compound interest formula straight down. Okay. Part A. Yeah, the value of the investment after 10 years. Well, definitely know that N is 10 years. The value of the investment, well, after an amount of time is how much it amounts to. That's the A value, right? If we come back to 21, the amount of A is the amount of the investment after a certain period of time. P is what it starts as. Okay, so we can just plug it straight in and we'll be right. P. Okay, P times 1 plus I, so P 2,500 times 1 plus 0.055 to the 10. 2,500 times 1 plus 0.055 to the 10. $4,270.36. Okay. And so that's how much it will be after 10 years. Like, I guess it's sort of nearly doubled what he initially invested, which is a good thing when you're investing. B, find how long it will take the original investment to double in value. How long will it take to double in value? Okay. So that's actually, let's have a look. So how long means we're dealing with time, right? If we come back here, time is to do with that N value. n is the number of years. So that's, want to know what we're trying to find. So it's this little power now we're trying to find. And to double in value, the original investment to double in value. So we want to know when when P is doubled. So an A is 2 times the principal, if that makes any sense. Because it's doubling means times 2. So let's just put that in. See what our A value will be. And then I think these are actually guess and check. So I'll show you what I mean by that. A equals P times 1 plus I to the n. So what have we got? A is 5,000 this time. Okay. P is 2,500. Our initial principal stays the same. 1 plus I as a decimal, 0.055 to the n. So what we're trying to do is we're trying to find an n value that will make this side equal 5,000, right? We need the left-hand side to equal right-hand side. What n value? All right. Now, so I can start with so from part A, it says after 10 years, it's not quite doubled yet. So I'm just going to start, I'm going to start with n equals 10. All right, we can save ourselves some time. I'm going to start with n equals 11 actually, because we know that it hasn't quite doubled at that point. Let's try n equals 11. So what I mean by this is we're substituting n equals 11 and we're seeing if it satisfies the equation. So it takes a little bit of getting your head around to get this. So we're checking, will this right hand side equal 5,000? 2,500 times 1 plus 0.055, 11. Okay, so it equals, we need to exceed this, right? We need to double in value. We need to reach that. So it hasn't quite doubled in value after 11 years. So it hasn't reached that. And what I can say is bringing that 5,000 down. Therefore, try again. Okay. N equals 12. Let's try the next number up. So 2,500, I'm just bringing this, I'm just testing to see if this might get us to 5,000 or above. Okay. Substituting in that n value, we tried 11, let's try 12. 2,500 times, hopefully we get there soon, to the 12. That gives us 4,753. Not quite. Not yet. Now, what you can do is save yourself some time. You have it in your calculator. And, oops, I just deleted it from my calculator, so that's great. Let's just try it again. One more calculation and then I just, I've shown my working. So we'll just, I'm sure your teacher will be fine with that. So 2,500 times 1 plus 0.055 to the 13. 2,500 times 1 plus 0.0. I'm going to keep it in my calculator this time and then just replace the power with the next one if we haven't quite reached 5,000. But luckily, we do reach it. We actually exceed it at this time. Okay. 5,000. Okay. Is less than that amount. So then we can say, therefore, it takes 13 years for the investment to double. You want it to exceed that that amount, if that makes any sense. Hopefully that makes sense. Yeah, it started as 2,500. After 13 years, it exceeds the $5,000 mark. Before that, didn't quite exceed it. So yeah, hopefully I didn't confuse you too much by scrolling around like that. But anyway, so that's the three questions we're doing on compounding annually. But this is for next time, all right? We're going to look at given an interest rate with monthly rests, or compounding quarterly or monthly or 6 monthly or fortnightly. Okay? So it's a little bit of a different process there. But that's why you're going to watch that video. All right. Have a good night.